All right, okay, so explain what the geocentric theory of the universe was. So obviously an older one, geo means something, geo means something. And then who stood behind this theory, which made it pretty hard to challenge. And then Copernicus. Yesterday we talked about Copernicus starting this organizer here of these scientists. Okay, we're gonna continue that. I'm thinking for a test Friday. Okay, no one's gonna be upset about that. It's good. All right, so I'm thinking a test Friday here on the Enlightenment, philosophers, and the scientific revolution. Okay, so use your organizers to help you. We went over the philosophers one last week, and then now here we're moving on to the scientists. I want to try to keep moving. Goal here is to try to get through the French Revolution, Napoleonic Age before Christmas, and I'd like to keep on pace here, so we can maybe get to the Cold War by the end of the year. That'd be great. So we'll see. Anyway, I'll give you guys some time here, then we're gonna keep moving. Oh, the project. I went over the project yesterday, right? The wanted infographic, the philosopher, the scientist. I think so. Patty Moore, I'd ask you, but you weren't here. Skipping.
Yeah.
Just joking. I did though, right, Eli? You were here, right?
Yeah.
Did I go over it? Okay. All right, so please pick a philosopher or a scientist. Make sure you put that in discussion post and indicate who you're working with, so everybody knows. Again, first come, first serve. Someone's already picked, you gotta pick someone different. All right? Okay. Bless you. All right, let's get to it. So geocentric theory. So what is the geocentric theory? What is it? Elena, go ahead. Yeah, good job, right? So this was thought of by the ancient Greek and Romans. Okay, we talked about Ptolemy yesterday, and we mentioned a little bit about Aristotle. Okay, back in the day, obviously, they were making observations both with the naked eye. So obviously a little bit difficult, a lot harder to do without common instruments like telescopes. But with their observations, they determined that the sun moves around the earth, right? That the moon obviously moves around the earth and all the other planets. So they believe that the earth was the center of the universe. Geo means earth. You guys got it? Okay, so geo means earth. That it is at the center. And everything else moves around it. Who backed this idea? Who backed this model? Brody. The church, right? Good. And if you're going to question this theory, right, then you're questioning the church. So again, with the church, they believe that God would put, right, his creation here, right, the center of the universe. Makes sense. So if you did question it, well, you're viewed as a heretic. Anyway, who comes around and questions this theory? In the 1500s, mid 1500s. Naomi. Yeah, Copernicus, good job. So Nicholas Copernicus, he questions it and says, I have a different idea. And what was his theory? What was this called? What was it called? Luna, go ahead. What? Oh, okay.
Heliocentric.
Yeah, heliocentric theory. Good job. Helio means what? Planet. Sun. Yeah, so the sun is the center of the universe. Obviously, for them back then, they didn't think the universe was that big, but obviously we know it's a lot larger now. So it's the center of our solar system, right? And all these planets here, even Earth, right, revolves around, it orbits around the sun. So heliocentric, meaning the sun is the center. Okay. So make sure you guys note that moving forward here. Anyway, Copernicus, as he was publishing his works, he was making certain observations, looking at the moon. He was looking at, bless you, bless you. He was looking at other planets like even Mars and seeing how it rotates, how it moves in the night sky, and thought, you know what, there's something different here, right? He thought that the sun has to be the center, not the Earth. So as he's questioning the geocentric theory and the church's beliefs, their doctrine, right? Did he do that right away? Did he publish his works right away, or did he wait a little bit? What's the story behind it? Audrina?
Um, waited till.
Yeah, good job, right? So he's that much of fear of the church and what they do to him, right? That he get banished, that he'd be viewed as a heretic, that he even be killed. So especially right around this time, we talked about with Martin Luther. He was questioning the church, especially when it came to its doctrine with the Bible. Sola Scriptura, right? The 95 Theses, calling out the corruption of the church, right? So with Copernicus, right around the same time, right? He's detailing about how, you know what? I think the church has it wrong. I think what we're practicing and understanding of the universe is wrong. Right, we got to look at it a different measure, a different theory. Then he comes up with a heliocentric theory. All right, good. Everybody good with that? Geocentric, heliocentric. All right. So good there, good there. Moving on here, we're going to continue talking about some of these famous scientists, these astronomers. And if we get to medicine today, that'd be great, but we will see. We will see. All right. Oh, last thing here. So what allowed for these new ideas to break out? What allowed for these new ideas and these new theories of how the universe, the world works here? How did it get out to everybody? What invention allowed this to happen? We wouldn't have it without this invention here. Jason. Yeah, the printing press. Good job. So I know I talked about it quite a bit before, chapter 2. But the printing press is allowing for these new ideas, these new theories to question these traditional views, these older views. And as you can see, the 1500s, we've been talking about a lot of these famous artists too, a lot of these philosophers, right? The Renaissance, the Reformation, the age of absolutism, the age of exploration, all this is happening right at the same time, right? The scientific revolution, it's all happened, boom, right in one instance. A lot of that has to do with that printing press. All right, here we go. So Newton's Principia. There you go. All right, here we go. Here we go. So again, guys, as we're going through the notes today, as we got to the scientists now, I'd like you to fill out this chart as we're moving through it. So you should have Copernicus done now. Real quick, let's do a review. Major work by Copernicus. What is it? Jason. Yes, good job. Perfect. And what should you do? Put it in italics, right? Capitalize. Okay. If you guys don't do that, well, you should get in a habit of doing it. Okay. That is important when it comes to famous works like a book, article, whatever it might be. So make sure you guys put that down for major works. All right. Background professions. What is he? What is Copernicus? So obviously a scientist, but what kind of scientist here? Looking up at the night sky, looking up into space, planets. What do we got here? Planet. Yeah, it's an astronomer. Good. So that would be a good, obviously a background profession to label him as an astronomer. Okay. Theories, discoveries. What was it again? What's at the center of the universe? So we said that in the day here. Nailed it.
One, the sun.
Yeah, the sun. Good job. Good. And what's that theory called?
The
Yeah, good job. All right. So his theory, his discoveries is that he came up with a heliocentric theory. Again, that the sun is at the center, right? I'd make sure you put that down right next to it. Okay. Right in that box. If you want to put, I don't know, a symbol, if you want to put a picture of the sun there, great. Right. How the solar system works. Right. Real quick though, one thing to note is that with his theory, the heliocentric theory, okay, he believed that the planets orbited around the sun in a perfect circle. Right. So he was kind of wrong, obviously, and center of the universe. I don't know about that, but in any case, right, that's something to note about his theory. Chloe, can you fill out pass? Can you fill out pass, please? All right, thanks. Okay, here we go. Moving on. Watch the video lesson, okay? All right, so with Copernicus' heliocentric theory, again, fill that out as we're going through. One big thing, like I mentioned, is that the fear of God was put into a lot of these guys here because they didn't know what was going to happen, right? As they're challenging these doctrines, these old traditional beliefs, you got to imagine the church wasn't too happy, especially after this Reformation. So here they're losing power as these new perspectives of religion are happening. And at the same time, now you got these guys here, these scientists critiquing their their understanding of how the world works. So yeah, they're not too happy about it. They're not too thrilled. Anyway, that's why he waited until his deathbed to publish his works. All right, real quick here now, Kepler. So as we're moving on here, Kepler is going to be one of the first scientists right after Copernicus that's going to prove that, you know what, he's right. Okay, as you can see, it's a little bit of time afterwards too. Over 50, close to 60 years, right? So 60 years later, he publishes works of the laws of planetary motion, right? So what does he do? Well, obviously, he's going to look up in the night sky just like Copernicus. He's going to use instruments like a telescope, like Galileo, who we'll talk about. And with these telescopes, he'll look at certain planets like Mars. I don't, it's always Mars, it seems, but he's going to look at Mars and other planets and see how they travel through the night sky. Right? As he's making these observations, he's realizing, you know what, Copernicus, that guy, he's right. Okay, thanks to that printing press, these ideas can leak out all throughout Europe. And he can focus on trying to spread it even further and try to prove it. So what is he doing? Well, he's making observations, right? He's using these instruments, these tools of science and understanding mathematics and seeing how throughout the night sky, these planets travel, how they move, right? He's making precise calculations to prove the findings of the heliocentric theory. So in other words, he proves what Copernicus was detailing here with his theory. Okay, guys, make sure you write that down here through your organizer. Laws of planetary motion, that's the same works. Okay, if you want to capitalize it, italicize it, great. Okay, what did he talk about? The orbits? Well, guess what? It's not a perfect circle. So this is where Copernicus was wrong, right? He said it was a perfect circle, these orbits around the sun. Okay, these planets travel in a precise and an exact circle, which is not right. Okay, and more goes in an ellipse, like an oval shape, right? And as the planets would move around, obviously, it would kind of force and pull the planets in this elliptical motion, right? In this oval, obviously this oval shape. So in other words, this ellipse, right? He's the one who kind of crowned the term here, is how these planets move throughout space around the sun. Okay. So we'll talk about with Galileo, right? We'll talk about even more with Isaac Newton, how they prove it even further. But real quick, Well, now we got these scientists here, these astronomers, right? So you want to put that down here for Kepler. He's an astronomer. He's a mathematician too. That's something you can put down here for Kepler. And yeah, he's using these instruments to try to prove that, you know what, Copernicus is right. This geocentric model, maybe we should forget about it, right? This thing is stuck here in the past. Again, yeah, he publishes his works, but at the same time, he's a little careful with it, right? He wanted to make sure that he wasn't viewed as a heretic himself, right? He was really cautious about what he was going to state here, what he was going to publish, because the church would be after him. Did I tell you guys about Galileo yesterday with the church and finally when they recognized his views, what year, his beliefs, his ideas, his theories of the motion, the movement, heliocentric theory, 1992. Isn't that crazy? This doesn't seem that long ago, right? That's finally when the church realized that, you know what, Galileo was right. Okay, which we'll talk about Galileo and his fightings with the church here soon. Anyway, there's Kepler though. Anything to remember? Laws of planetary motion. Okay, and he realized that, you know what, it's not a perfect circle here where these planets travel around the sun. It's actually more in an ellipse. As you can see, the sun, one or two foci here, as it's moving, as it's being pulled. Again, he doesn't come up with these mechanisms here of how the planets move, right? We'll talk about Isaac Newton here and mention about how this motion occurs, how gravity is used to try to pull these planets around a larger object like the sun or like the moon around the earth. All right, moving on here. All right, so Galileo, just talked about him a little bit, but anyway, what did he do? What was his fame, his claim to fame? So we all know him with the telescope. Okay, what kind of telescope did he use? Reflective or refractive? Refractive. So you used a refractive telescope at the time, which was kind of new, kind of new. Anyway, this would bounce light back and forth to try to understand certain objects that are closer up in a little bit more detail. So what did he observe? Well, he observed Jupiter has 4 moons. Wow, that could go out pretty far, right? And he's using light that is being bounced off these mirrors, these lenses, so to speak, in order to try to see and depict these certain objects. Is it a clear picture? Not the best, obviously back then, but in any case, he was one of the first here to observe these moons, these planets from far distances, from Earth, obviously. Anyway, so what is he known for? He's a father of modern observable astronomy. So if you want to put that for his background, his profession, yeah, he's an astronomer as well. Okay. Also, he was an engineer, right? So he wasn't just an astronomer, he was also an engineer. So we'll talk about with clocks, right? With motion too. Okay, you guys ever see a pendulum swing back and forth? Right? He actually was one of the first here to understand how this movement occurs and how that could be applied to a watch, the mechanisms of a watch. So that's something important here that Galileo, a lot of people don't think of. Father of modern science, that'd be good too, obviously to put by his background. That's something important. He gets claimed to fame a lot of things because of his observations with the telescope. All right, anyway, what was his goal? His goal is again to try to prove this heliocentric theory. So here's where he gets into a lot of trouble with the church because he's vocal about it. He starts to explain that, yeah, you know what? Copernicus was right, okay? And he's right around the same time as Kepler. So this is about 50, 60 years after Copernicus, but in any case here, he's proving that the heliocentric theory is right, that it is correct, okay? So what did he observe again here? So other things that Jupiter has 4 moons, and he looked at the motion of these moons around Jupiter. Said, hey, something similar has to happen here on Earth. And obviously he looked at our moon, right? He realized that this rocky surface, right, this uneven surface is a lot different than what we see here on Earth. And there has to be a reason for it. Maybe the atmosphere, maybe some other reasoning, but he's making these observations, first person to do so. All right, he also looked at the sun. The sun has dark spots. What? So it wasn't just this big ball of light, it's something else, right? There's something else happening here, like this nuclear fission constantly bringing this light, bringing this heat to Earth. So in other words, with these observations, he's focusing in on a lot of things that is proving, again, this heliocentric theory and looking at these planets and how they move around the sun and making basic observations of our moon, but also Jupiter's 4 moons and how they obviously orbit, ellipse around Jupiter. So he's proving a lot of the heliocentric theory. All right, here's some of the problems. Like I mentioned, the church isn't happy about it. So what happens? They put him on trial. Geez, the church put him on trial? Yeah, just like what we saw with Martin Luther. In other words, though, they want him to recant. They said, hey, you're challenging the church's doctrine. This isn't good, right? Here are specific parts within the literature of what we know the Bible of religion, saying that, you know what, the earth is the center of the universe. And for Galileo, he says, well, this is wrong, right? We need to move past this. Okay, he's not anybody that's trying to, you know, obviously get rid of his religion. Okay, he's not someone that is, let's say, an atheist. He's not that at all, right? He actually believes in religion. He believes in God, but at the same time, we need to come up with these different measures, these different theories to actually explain what's happening, right? We need to make our own observations, right? We need to make our own experience and then understand the world around us. We just can't go by this doctrine that's been stated for thousands of years, right? We need to move past it. So in other words, he's trying to give birth here to this scientific revolution. And that's why it's considered this father of science. Okay. So what does he do? He looks at certain scriptures, right? And he explains that, you know what, we need to move past it here. Okay, this is wrong. Okay, this is not correct. But, and again, he's not disowning religion. He's just saying that we need to learn from it, right? We need to look at the past here and say, you know what, this is great and all, but right? Let's make our own viewpoints, our own theories, our own observations. And like he did with the telescope, he's proving, right, through observation, what is correct and what is right. All right, anyway, moving on here. So faith and science, like I said, for Galileo, he argues with the church. And, well, what do they have him do? They want him to recant. They want him to take back what he said. And Galileo, do you think he does it? Like Martin Luther, Jason? He does. Oh, geez, darn. So he does recant it just because he was in that much fear, right, of what would happen to him, right? Obviously, it seemed like Martin Luther, he was protected, right, by Frederick the Wise, you remember? Okay, good. For Galileo, he didn't know what was going to happen to him. So he was in that much fear. Okay, he's in Italy as well. So you got to imagine the Roman Inquisition. I know I talked a little bit about that, but they were after him. So they said, hey, you got to recant, you got to take back what you said about this geocentric theory. You're questioning the church, you're questioning the Bible and the scripture. This isn't right. He's like, listen, I don't think that people should give up religion. I'm just saying that we should learn from our own observations and make our own interpretations of how the world works, how the universe works. And they said recant, and he did, right? So what happened to him? He was put on house arrest. So as he was put on house arrest, he didn't stop his findings. He didn't stop his research. He didn't stop his scientific discoveries. And that's where he made a lot of these observations here to actually prove this heliocentric theory, when he was using the telescope to look up at the night sky. So in other words, I guess that way, all right, of them putting him on house arrest actually helped him out more to prove this heliocentric theory. Anyway, so for Galileo, like I mentioned, in 1992, the church would come around and say, you know what, we're sorry about it. We messed up. We can maybe move on and actually try to prove, right, that he was correct. So it did take a long time. 300 years? Imagine that, right? Over 300 years. It's crazy. Anyway, there's Galileo. Italian, an Italian astronomer. If you want to put an engineer, that'd be good too. So like I mentioned with the pendulum swinging, that helps with, obviously, with watches, with time and clocks. So that's something, again, that he kind of found and that many people don't give him too much credit for, I guess, or you don't really think about it too much. All right. Isaac Newton. I'm sure you guys heard of him before. What fell on his head? Huh? Wyatt? The apple, right? Okay. So that story comes up a lot. Did it actually happen? I don't know. Maybe, maybe not. But with Isaac Newton, he comes up with these laws of gravity, right? That, hey, something had to draw that apple down to fall on top of my head. Something has to actually have these planets move around a larger object like the sun. And what is it? Well, he does come up with the laws of gravity. He says that these objects here that are obviously closer to the ground of Earth here, they're going to have a stronger pull, a stronger gravitational pull. Once you go out into space, though, there isn't such thing, right? There isn't really, there's a lesser form of gravity, right? But in any case, with these larger objects like the sun, the planets move around it. There's some sort of gravitational pull that's moving these planets around the sun. And as you get further and further out, these ellipses, right, this gravitational pull is a lot less. I wanted to mention with Galileo too, he did look at Venus, right, the planet Venus, and he made a lot of observations with that. And obviously that's the one he indicated that helps with understanding the heliocentric theory. All right, back to Isaac Newton. With Isaac Newton, what else is he famed for? What other laws here? Laws of what? I throw something at you, it's moving, right? The laws of motion, right? Okay. So with Isaac Newton, okay, he's famed for trying to understand exactly how these heavenly bodies, right? How these planets move around the universe, right? It's one thing to understand it, to make these observations, but how does it work, right? All right. So anyway, laws of motion. What do we got? What is one law of motion here? How does this work? What do you guys remember it? Wyatt, you got it? What's the first law of motion? How about any of them? Okay, good job, right? So when you think about the law of inertia, okay, so when it comes to an object in motion, stays in motion. An object at rest stays at rest, right? So when you think about playing soccer or something, you put the ball down, it's just sitting there until you kick it, right? So once you kick it, something has to stop it. What stops it? I don't know, maybe someone else playing, right? Someone kicks the ball or maybe stops it from going into the goal, right? Or, I don't know, gravity, I guess, huh? Okay. What else? What else do we got here? Peyton, go ahead. Yeah, good job, right? So when it comes to maybe a second law of force, mass times acceleration, okay? So depending on the mass of an object, right, that's going to accelerate at a different speed. So good example, I don't know, you're at Walmart, you're filling the cart up with a lot of these products here. I don't know what it might be, certain groceries. When you're first pushing the cart, not a big deal. It's not too hard. But as soon as you get that cart filled up with a lot more of these products or a lot of these groceries, you got to put a little bit more effort, a little bit more to move it. So yeah, good. That's a good example. So a little bit more of a force depending on the mass. All right, what's another one? What's the last one here, I guess? Elena. Yeah, good job, right? So as maybe you're running, okay, you're jumping in the air, as you have that force, that reaction, it has an opposite, that action, it has an opposite reaction. A good example, I don't know if you guys ever jumping out in like a smaller boat, let's say you're out in a river or a pond or something like that. Once you jump off of it, the boat actually moves a little bit, right? It moves backwards, it kind of comes back. And that reaction happens when you're jumping, right? Like opposite reaction. So as you're jumping off that boat skids back a little bit. Obviously, a lighter one. Yeah, the heavier one is going to be a little bit different, but with that opposite reaction. So good. There's Isaac Newton. So you guys do know a little bit about Isaac Newton. What else do you know about him? Anything else? Anything else? Jason? Yes, good job, right? So a lot of people said he kind of lost his mind towards the end, and he did become an alchemist. He was trying to turn things into gold, different objects. It's like, what happened here? Jeez. Anything else about Newton? Anything else? The light spectrum, you guys ever heard of that? Optics, anybody? Okay. Do you know he actually stuck a needle into his eye to try to mess with the photoreceptors to actually see different types of light? Is that weird? Can you imagine doing that, Eli? Oh, geez, it makes me queasy just thinking about it. Anyway, so he was fascinated by optics actually during a time of his life here. In the early 1600s, there was another plague that broke out. So this is where he did a lot of his studying with optics and light and understanding more of the light spectrum. So it's actually interesting about him with optics. So if you guys ever if you guys get a chance, maybe look into that a little bit more. If you take psychology with me, we'll actually focus on the light spectrum. We'll do a few labs and can understand, different types of color receptors and even different types of rods and cones within your eye and how he was trying to understand it to a point where he actually tried to mess with him with a needle. Unbelievable. He actually went partially blind. Isn't that weird? Strange? I don't know. Anyway, there's Isaac Newton. Interesting. Considered one of the first geniuses. One of the first. Gotta imagine. All right. Anyway, with light and optics, okay, as that light was shining through, he had a somewhat of a mirror, somewhat of a prism that shined down, and you could see the light, you could see the color. What's up? Are you kidding? So he was an astronomer. He was also an engineer, if you think about it. He was also one that dealt with optics. So there's many, many things you could list here for Isaac Newton. Physics, right? So when it comes to physics, obviously that's something important. So an engineer that you can list for his background, his profession. All right, so moving on here. So when it comes to gravitation, so here's a little bit more of a better example of gravity when he talks about this world machine concept. All right, so he calls it this world machine concept because he's trying to understand how things move around, right, the sun, right? Obviously, there's a bigger object in the solar system here, the sun, and these smaller objects, these planets, will move around it based off of this gravitational pull. The further away the planets, obviously, that ellipse, that orbit's going to be a lot further distance. It's not going to move near as fast. The closer you are, the stronger the gravitational pull, right? The faster these objects are going to move around this larger object, like the sun. So, in other words, he's proving, right, with this world machine concept. The biggest question, and still no one can answer, is what started this? What made this happen? Right? Some say the Big Bang Theory. What is the Big Bang Theory? Anybody? Why?
The universe was created with Big Bang.
Yeah, it blew up and then everything kind of expanded after that, right? And then how this caused this motion, how this caused with gravity pulling these objects around the sun and all these different solar systems forming. All right, good. These galaxies even, holy cow. Right, there's other ideas too, but Newton believed that God started this, right? Someone had to make this happen. Someone had to make this happen, or this Big Bang, let's say. So with this world machine concept, one thing to know with Newton is that he was religious, right? One thing a lot of people think of when it comes to the scientists that we're discussing, that they didn't believe in God or religion. That's not true. They actually did, right? They're just trying to come up with these better answers to understand the world around them. They try to make it more sensible, right? But he believed that this world machine, right, it had to get started from something. And he believed that God started it, right? And how this movement we can make sense of. So that's something interesting that you guys should know. All right, other scientists. Now we're moving on to the anatomy of the body. All right, so when it comes to the anatomy of the body, it was believed back in the day with Galen, ancient Greek and Rome, all right, Greece and Rome here. They believed that blood just kind of sloshed around in the body, that it wasn't pumped, that there was just, I don't know, you're just standing there. This blood just sloshed around. It wasn't, in any case, getting circulated around the body. Later down, Galen described that, maybe when it comes to the veins and arteries of the body, because he was dissecting animals, it was inhumane to dissect human bodies. So his only understanding of the circulatory system and the anatomy of the body was through animals. So obviously that's a little bit different. And they believe that the liver was the one that controlled veins when it comes to bringing this blood back to get oxygenated. And then the heart, obviously, is the one that pumped the blood, so to speak, later down the line here, and gave the blood oxygen to move, right, and give these muscles some sort of movement. So Galen, he was a little outdated here, but in other words, he was getting on the right track here. That it wasn't just sloshing around your body. There's some sort of pump that was oxygenating this blood. He believed that there was two systems, so obviously in the body when it comes to the liver and the heart. So he was off a little bit, but well, you got to give him some credit here because he was only dissecting animals. He didn't really understand the human body because it was believed heresy, right, that you would cut open the body, right? You couldn't do it. The church forbid it to happen, right? Later down the line, we get the scientific revolution, 1700s. Many people decided, well, let's just cut open some bodies here. And the one guy we're going to talk about, I guess more tomorrow, he'll actually cut open some bodies of his own family members. What? Geez, so strange, weird, I get it. But, well, when it comes to the sciences, you'll do anything to try to prove your point. So we'll talk more about medicine tomorrow. We'll talk more of the anatomy of the body tomorrow. All right, there you go. Galileo, Kepler, right? Newton, good stuff.